All right, ready, go. All right, what do we got? Just drop it in the top box there, thanks. Okay, the answer to this one, I've been around and seen just about everybody's. The answer was 98. Not Q8, 98. Okay, let's try this one. Okay, multiply it out and simplify. Here's your answer. Right there, 8 minus 2 root 6. Saw that on just about everybody's board at some point or another. All right, let's do one more here. Ready, go. Okay, so we're at about 70-something% right now on our intro video. So that's the weakest of the unit at this point. Got a few more this year. Let's try to do a little bit better. Some of you might feel mildly lost today. We'll see. Hopefully we can get you up to speed. So the intro video was this material right here. Our final part of this unit is going to be working with equations that have radicals in them. And so in the intro video, just a real brief explanation, and then I worked a couple of examples for you. One note here that was in the video that I want to re-emphasize to make sure that you've heard it again is this right here. When you are solving these radical equations, you need to be sure that you check your answer, and here's why. This is another one of those situations like we did before where it is totally possible for you to do everything right and do all the steps perfectly and make no arithmetic errors and get one of those extraneous solutions. Do you remember those? Where it's an answer that just does not work. It's something that does not make the original equation true. And so we want to check to make sure that the answers we get really are truly solutions. Okay? So like I said, I just wanted to re-emphasize that for you. And let's do some examples. So I think you'll find number 3 is really similar to the intro video. So I'm labeling this as a warm-up, as in something where if you were successful with the video, this should go okay for you. So please try number 3, and I will go over this one with you here in a couple minutes. Ready, set, go. Go over some steps here with you. We'll do like 3 or 4 of these today. We should get in some practicing today. We'll get in a ton of practicing tomorrow. If you've been keeping up with your calendar, you know that we've got a quiz on Monday. This is the end of the unit right here. So our 8.3 to 8.5 quiz would be Monday. All right, so here's what we would do with this one. Again, just referencing back to the video. I'll just rewrite this here just so I can have a little more space. I've got this going on right here. I'm supposed to solve for x, which means I'm supposed to get the x by itself. And the only thing really that's new here is the radical, right? So once you've got that radical isolated, and you see the radical is all by itself, we can get rid of the radical by squaring both sides. So what I'm going to do here is I'm going to square the left side, and I'm allowed to do that as long as I also square the right side. Okay? But I want to emphasize this again. Are you listening? This really only works if you have the radical by itself. And do you see how the radical on the left side is by itself? It's radical 5x. There's nothing being added or multiplied or divided by that radical. The radical is by itself, so all I have to really do is just square both sides to get rid of it. On the left side, I kind of like this notation. The radical cancels with the squared. They cancel each other out, leaving me with simply 5x minus 3. And 4 squared is 16. To finish this off, I'm going to use the regular equation solving methods that we learned back in, like September, October, something like that. Am I going to get rid of the 5 first or the negative 3 first? And how do I get rid of the negative 3? Got to add 3. Yep. So these are those old equation solving steps. That gives me 5x equals 19. And then how do I get rid of the 5?
Divide.
That's right. Dividing by 5 gives me 19/5. And so that is my potential answer. I think it does end up being the answer, but I do need to check. Here would be a way to check. I'm going to come off to the side. I'll use a different color here. And here's my check. I'm going to write square root of 5 times 19/5 minus 3 equals 4. And I'm hoping that this is true. What would happen with the 5 and the 5 in the radical? They would cancel right on out. Yep, so the 5 would cancel with the 5, leaving me with this. And 19 minus 3 is 16. And look at that. Square root of 16 is 4. 4 does equal 4, so it checks, and I would say we've confirmed 19/5 really is the solution. There are going to be times when you go through all that, you did everything right, and it's going to be like, oh, wait, that's not true. Then you go back and say, well, that's not a solution for this equation. Okay, so that was very video-like. Any questions? Follow-ups? Yeah, Grace.
So do you just write not a solution?
Yeah, if we had gotten like 8 equals 4, therefore our check, something that's obviously false, so you'd go back and say, well, 19/5, that's not the solution. And if that,
you just keep retrying to
well, no. So if the only possible solution we got was 19/5, then we just proved that actually doesn't work, we would say no solution. You're going to find that sometimes there are 2 solutions, or you could even have 3 or 4 or 20 solutions. Not in this class. You could have lots of solutions. So it's possible that if you had 3 solutions, one of them might work and 2 of them wouldn't, or some combination. Any other follow-up questions? Okay. I think this is going to get a little bit more interesting. That was very video-like. This is a little bit less. Same principle. And I am ultra curious to see how you do with this. This is going to be, I think this will be really interesting.
I don't even know what
Same principle. So will you guys try this? I mean, maybe it goes great. Maybe it goes terrible. I don't know. I really don't know. We'll see. I hope you do great. I think you can do it. Hey, listen up. I'm going to show you some stuff here that you might not have thought of, but you might think of later, and I'm going to try to head you off so that you don't make these mistakes later. Can I show you guys a couple of common errors? Can I explain why they're not good, and then maybe give you a visual on why, how to remember this? So this is always tempting. I've seen this with multiple folks every year that I've taught stuff like this. Are you watching? I hope you're watching and you're really focused, because what I'm about to do is incorrect. All right, it's incorrect. But I want you to think about why someone might do this, and we'll talk about a way to remember this. So I've seen this plenty of times. Are you watching? Are you watching? You should be.
No, that's exactly.
Hey, you should be watching. I'm so sorry. I know I'm interrupting. So this is wrong. You can't pick little pieces out of the Radican and start adding or subtracting or dividing or whatever. You can't do that because it really isn't a 45, right? It's like part of a square root with a 45 in there. You can't do that. You can't also, maybe subtract 9x or something. You can't do any of that stuff simply because those elements are inside the radical, and you're not going to be able to, cancel them out the way that maybe you normally would if the radical wasn't there. It's there. And so you have to deal with it as is. Here would be my analogy for you real briefly. You guys all know what a safe is that you would keep valuable stuff in? Like a safe, like a big metal box. I want you to think of the radical as if it were a safe. Okay? And you can't reach in there and play with the 9x or steal the 45 or do something with the x squared. You can't do anything with any of those things until you've opened the door to the safe. And that's the getting rid of the radical part. That make sense? Maybe that'll help you remember. Anyways, so what you would do here is the radical is isolated. It's all by itself. So we're going to get rid of the radical by squaring both sides. So square both sides. That number one, that's going to get rid of the radical. The radical is isolated. Get rid of it. So the left side would then just be x squared. The right side would be the canceling of the radical and the squared. X squared plus 9x minus 45. In other words, we've opened the door to the safe. All that stuff in there is now out in the open, and we can do stuff that we need to do with it. That make sense? So as I was walking around, a decent number of folks got to this stage, and I was like, okay, what am I going to do? And I saw people looking at the idea of the magic x, and how could I figure out which numbers multiply to be this and add to be that? A word of caution here. Do you see how this is not in standard form yet? isn't standard form, ax squared plus bx plus c equals 0. So you need to have everything on one side equals 0 on the other side. So how would I get to that stage? How would I get to the place where I've got equals 0? Subtract the x squared over. That's exactly right. So when I do that, this really opens everything up. This actually makes this a much easier looking question, because what is x squared minus x squared? 0. That was the whole point. So 0 equals, well, look at that. X squared minus x squared, those add out to be 0 as well. So we end up with, on the right side, simply 9x minus 45. So when you try to put this in standard form, don't you realize this really isn't a quadratic? It's really just a linear equation. So the way you'd finish this is you do the standard equation solving methods. Do I get rid of the 9 first, or do I get rid of the minus 45 first? The minus 45, yep. So plus 45 to both sides, and that gives me 45 equals 9x. And then to get rid of the 9, what do we do?
Divide by 9.
Yep, dividing both sides by 9 gives me x equals 5.
Ooh, that makes
Okay.
so much more sense.
Good, good. Okay, so then we got to check these. We always want to check these. Here's what the check would look like. I would write 5 equals the square root of 5 squared plus 9 times 5 minus 45. On the right side, 5 squared is 25. 9 times 5 is 45. And look at that, the 45s add out, don't they? Positive 45 minus 45 is 0. 5 equals square root of 25. And look, it is true. It does check. Therefore, the answer is 5. So you always want to do those checks. It's very possible to do everything right and get one or more answers that are actually don't work. You guys hanging in there? Any questions? Okay. Let me decide what I want to do here. So there's that one. You know, I definitely want to go in order here. Let's do 5. Let's do 5. And I want to direct you just a little bit with 5. Hey guys, listen up. I just want to give you one little direction here and then let you guys roll with it. Do you see how, if you compare this to numbers 3 and 4, and even the ones on the video, do you see how this is the first time? Please, you should really be listening right here. I'll let you just run with it from here. Do you see how this is the first time where the radical is not by itself? What's with the radical? The 6, the plus 6. So if I'm going to get the radical by itself, what would I need to do with the 6? Yeah, subtract it over. So minus 6 from both sides would give me minus 6, minus 6. So I'd get square root of x minus 10. 2 minus 6 is negative 4. So if you guys would, maybe from here, see if you can solve it using the methods we've been working on, right? The radicals by itself. Go through your steps from here. See how it goes. So we got to this stage a second ago. Did you guys, for your next step, did you square both sides?
Yeah.
Okay, so that's what we want to do. So we're going to square the left side. We are going to square the right side. The left side, the radical, and the squared cancel each other out. And on the right side, what is negative 4 in the parentheses squared?
16.
It is 16. Guys, you should be paying attention right here. We're going to get into the details. So to solve this, all you'd really need to do is go plus 10 to both sides. So x is equal to positive 26. And if you stopped right here, you'd probably feel really good about this. And I don't think you should feel bad about this because we've done everything right, but you haven't checked it yet, right? So we need to always check these because we have the potential for those extraneous solutions. So with this, you want to take your 26 and you want to check it in the original. You don't want to check it on any of the in-between steps. Check it in the original. It's got to be the original. So this would be square root of 26 minus 10 plus 6 equals 2. Of course, 26 minus 10 is 16. So we get square root of 16 plus 6 possibly equals 2. Well, square root of 16 is 4. So 4 plus 6. And then now we're running into issues, aren't we? Because 10 does not equal 2, obviously. And so you might, this might cause you some concern. You might think, well, gosh, did I make some little arithmetic error in there somewhere? That's possible. That's possible. We haven't made an arithmetic error here, yet the solution we got didn't actually work. And so because of that, the one solution, because it didn't work, we would not say x equals 26. We would say there is no solution, and that's our answer. There is no answer. There's no way in other words, what that means is there is no number you can plug in for x to make the original equation true.
So when you had 6, you plugged into the first equation?
You have to plug it into the original because that's the one we're solving. If you plug it into a middle step, that's actually a different equation than what we started with.
Okay.
Like after you squared both sides or whatever.
Okay.
Yeah. Jake, your question?
That was my bad. I was like, oh, I just figured.
So at the start, like why didn't you, could you subtract the 6 on both sides? To get -4 and that's square, like -4 times -4.
Makes the positive. That's actually where the issue happens.
So that doesn't always during.
That's going to be an indicator that you have an issue.
Well, like, subtract the 6 from both sides.
Yep.
And you get square root of 16 equals -4.
No, square root of 16 doesn't equal -4. Square root of 16 equals 4.
No, but just in the equation, like, just saying like -16. If you subtracted the 6,
Yep.
you got -4.
Yep.
But -4 times -4 is 16. But that isn't the square root. Like it, because
So-
-4 equals
Okay, well, what you're telling me is that -4 times -4 is 16, and also +4 times +4 is 16. I get that. When you see this symbol right here, right there, that symbol has a very specific meaning. It means the positive square root of 16, not the positive or the negative or the negative. It just means the positive. So you got to take the positive side. Okay, guys, we got about 6 minutes left. We're going to be in a good spot. I want to do one more with you. Hey, listen, please, you've done pretty well. Let's focus and finish well. I want to do one more with you, and this will set us up really nicely to get a lot of practicing in tomorrow, and that's number 6. I want to do this one with you. There's going to be some good stuff, some good review within this. So as you guys look at this one right here, do you all see how the radical as it stands is not by itself? So what's with the radical? Minus x. So how would we get rid of minus x? That's right. So I'm going to go plus x on both sides. That's going to give me the square root of x minus 2 equals x minus 4. And this is going to be kind of our next level of question. I'm glad we're finishing with this because we'll probably start with this again tomorrow, do a lot of practicing. The radical is by itself. So can't I get rid of the radical? How do I get rid of it? Square both sides. So it's the same principle we've been doing. So I'm going to square this side. I'm going to square this side. The left side is by far the easier side because the square root and the squared will cancel, leaving me with x minus 2. But on the right, what must be done? FOIL. You see it? We've got to expand this. So it's going to be x minus 4 times x minus 4. And I need to expand this and FOIL. So let's do that. So it's going to be x minus 2 equals x squared. And then your middle term is going to be minus 8x. And then your last term is 16. You have to FOIL this, right? Because you're squaring a binomial. So now, remember earlier today when you guys were trying to do magic x kind of stuff? Remember, before you do any magic x kind of stuff, we need to get to standard form. And standard form is everything on one side equals what? 0. So how do I get this to equal 0?
You add 2.
Add 2
And subtract it.
and subtract x. That's right. So that's going to give me this. And then I'm going to subtract x appropriately. That's going to give me 0 equals x squared minus 9x plus 18. So we want to get everything on one side equals 0. So now this actually is a quadratic. So magic x kind of stuff applies. So we need to factor, right? So anybody have any idea about the factoring of that right side? X squared minus 9x plus 18.
6 times 3.
Hey, there we go. So he's on the right track with 6s and 3s. It's got to be -6 and -3 because of the -9, right? So this is going to be 0 equals x minus 3 times x minus 6. Remember that old factoring stuff? It's going to keep coming up. It'll come back up in Unit 9 as well. So once I've got 0 equals those two factors, how do I solve this? Sorry? Well, if I FOIL it, I'm just going to go back to where I was.
X squared particular 6x in parentheses and then
No, I'm not hearing the wording I want to hear. Ashley. Zero factor property. That's right. So we said each of the factors equal to 0. So it'd be x minus 3 equals 0, or x minus 6 equals 0.
So this is where you have to check it because there's two answers.
There's two answers. Yes, so we're going to get x is equal to 3 from the first one, or x is equal to 6 from the second one. Do you see how this is tying everything together so neatly? All the stuff we've been doing, all that quadratics and factoring. You know what? You're right. We need to check this. Let's check it real quick. So let's see here. If I check 3, I would get square root of 3 minus 2 minus 3 equals negative 4. So square root of 3 minus 2, that's just 1. 1 minus 3 equals negative 4. And look at that. I don't think this works, does it? Negative 2 equals negative 4? I don't think so. So I would say based on that, 3 didn't check, it's out. Will 6 work? Let's find out. So if I'm going to check 6, that would be square root of 6 minus 2 minus 6 equals negative 4. 6 minus 2 is 4.
Wait, but isn't it negative?
Right. 6 is right.
Sorry?
Isn't it negative 6?
No, because you add 6 to both sides? Can I finish this?
Yeah.
You good? Okay. So then you get 2 minus 6 equals negative 4. Hey, wait a minute. That's true. 2 minus 6 really is negative 4, isn't it? So I would say that that checks. And so that is a solution. So our only solution would be x equals 6. So I'll leave you with this thought. Does that feel like something we should practice a little bit?
Yeah.
So tomorrow is going to be all about practicing that. Okay? Have a wonderful day. See you guys.